This is Ham College episode 77 for May 31st, 2021. Ham College is brought to you by Icom. Be a field day leader this year with Icom. Well, good evening, everyone. Welcome to another episode of Ham College. I'm Professor Thomas.
And I'm Dean Martin.
And it is going to be a hot time in the old town tonight.
It might be hotter than you think.
Yeah, there's something emitting an electrical smoking smell in here. It might even be a little smoky in here.
It is a little bit smoky. I can see it up there by the lights.
Yeah. So if all of a sudden the fire alarm goes off and you see the faculty leaving,
try to keep up.
Yeah. Okay. All right. Well, tonight's episode is, I don't think these are going to be as rough as they have been. At least I know they're not as tough as last week.
Yeah, I heard you and General E. Cheap had a little bit of a tough time on that one. May have been records set on that one.
We did. Yeah, I think we had 3 buzzers on the last episode. It was a tough class, man.
I believe that is. Yeah, I picked a good one to play hooky.
Yeah, you did. Very good one. You're going to get off easy on this one. Last time, though, we talked about radio horizons, ground wave, propagation prediction techniques and modeling of effects of space weather, parameters on propagation.
It sounds like fun stuff.
Well, it is, and it's a lot harder once you start answering questions about it.
I'm sure.
So what are we talking about this time?
That's a good question. Test equipment, analog and digital instruments, spectrum analyzers, antenna analyzers, oscilloscopes, RF measurements, and computer-aided measurements. If we're having a live show, there's usually a chat. Well, there's always a chat going on at AmateurLogic.TV /chat. There's quite a few people in there, and they kind of answer along the questions with us as we present them. And so it's a lot of fun, a lot of hijinks going on in there. If we're doing the live show and you're not in the chat room, you're missing half the fun. Take it away.
The question is, which of the following limits the highest frequency signal that can be accurately displayed on a digital oscilloscope? Is it A, sampling rate of the analog to digital converter?
B, the amount of memory?
C, Q of the circuit?
Or D, all of these choices are correct? Which of the following limits the highest frequency signal that can be accurately displayed? That's not the. I know it's not going to be all the choices are correct because I don't think the amount of memory has anything to do with it. I think it's going to be A, the sampling rate. It makes sense to me. The highest frequency, so it needs to be sampled faster to be able to be able to detect it.
I'll agree with you. I think it's A, and those who are answering the test over in the chat room, so far, they're all saying A.
A.
Is that a Canadian A, or is that an A like Fonzie?
That's like Fonzie.
Okay.
A really poor imitation of it.
Well, let's just see. And it is.
Hey, we can do that for real this time.
Look at that. One. You know, it actually does work better.
It does.
Yeah. When you're like 5 miles away, it's just kind of hard.
I'm just trying to figure out which side to...
Yeah.
Which of the following parameters does the spectrum analyzer display on the vertical and horizontal axis? A, RF amplitude and time.
B, RF amplitude and frequency.
C, SWR and frequency.
Or D, SWR and time. Which of the following parameters does a spectrum analyzer display on the vertical and horizontal axes? Okay. Spectrum analyzer doesn't display SWR at all, so you can rule out C and D right away. And then our choices are RF amplitude, for sure. That's got to be one of the answers. And the other is a choice of time or frequency. And I just happen to know it's B, RF amplitude and frequency. What do you think?
I agree. An oscilloscope basically is A.
Yep.
B would make sense. That would be the spectrum analyzer.
Yep. That's what everybody's saying over in the chat room. So to everyone in the chat room,
here's to you.
Yep. Okay.
It's pretty good under pressure. You know, the whole pressure with fire and all that stuff.
It is.
Smoke.
So far. Which of the following test instruments is used to display spurious signals and or intermodulation distortion products generated by an SSB transmitter? Is it A, a watt meter?
B, a spectrum analyzer?
C, a logic analyzer?
Or D, a time domain reflectometer? Which of the following test instruments is used to display spurious signals and or intermodulation distortion products? That's got to be B, a spectrum analyzer. A watt meter doesn't do that. A logic analyzer doesn't do that. And I honestly don't know what a time domain reflectometer is, but I can't be right. It's got to be B, a spectrum analyzer.
So everybody's saying it's B.
So you say it's B.
Yeah, I'm saying it's B too.
Well, I'd be right.
Okay. We know it's not a watt meter.
Definitely know that.
And it's not a logic analyzer.
Yeah, we know that too.
And a time domain reflectometer.
We now know that that's not it as well.
No, and what it is, our time domain reflectometer does, is you can hook it to a transmission line or a piece of wire or whatever, and it shoots a pulse down that wire, and the thing measures how long it takes for that pulse to go out there and hit something and then reflect back to you. And you'll also see how much of a reflection there is, how much is reflected back. But it's the length there. That's why they're calling it time domain, so that you can tell on a piece of transmission line, say it's a 100-foot piece of line, and you've got a splice in it at 50 feet, and you got water in that splice. The time domain reflectometer can tell you at 50 feet out, all of a sudden the impedance jumps way up or goes way down or something changes. It's something you would use to tell how far down a piece of transmission line an issue is.
Okay.
If you had several pieces of transmission line all coupled together and you had a real sensitive one, you could look out there and you'd see a little bump in the impedance everywhere there was connection in it. Mm-hmm.
Interesting.
Yeah. Chip says used to find faults in long wire and or cable runs. Yep. Kevin has a reflectometer in his bathroom just above the sink.
That almost just flew right over.
I could see it.
Yeah, you probably heard it buzzing by, didn't you? Yeah. How is the compensation of an oscilloscope probe typically adjusted? A square wave is displayed and the probe is adjusted until the horizontal portions of the displayed wave are as nearly flat as possible.
B, a high-frequency sine wave is displayed and the probe is adjusted for maximum amplitude.
C, a frequency standard is displayed and the probe is adjusted until the deflection time is accurate.
Or D, a DC voltage standard is displayed and the probe is adjusted until the displayed voltage is accurate. How is the compensation of an oscilloscope probe typically adjusted? And this is one of those things I was thinking maybe we would look at tonight. It's not a DC voltage that you're trying to adjust, so it's not D. C, a frequency standard is displayed. No. B, a high frequency sine wave is displayed. No. Typically it's a low frequency signal and it's a square wave that you're going to be looking at. So I'm saying it's A, a square wave is displayed and the probe is adjusted until the horizontal position or the horizontal portions of the displayed wave are as nearly flat as possible. So on the side of most scopes, somewhere on the scope, there's a calibration point where you can hook your probe on something and you get a square wave there. And
yeah, it's like a little 1 megahertz post.
And if you flip your scope probe to say minus, or not minus, if you flip the probe to the times 10 position, times 10, that just basically is a divider or an attenuator. Sort of, it reduces the signal, so whatever you're putting into the scope is going to be 10 times as high as what the display says. But, there's a place in your scope to tell it on these new ones whether or not you're using a times 1 or a times 10 setting. But if you put it on times 10, it becomes pretty obvious that square wave, should be nice and square corners on it. They'll kind of droop or go the other way. It won't be flat across the top, and you adjust that little trimmer potentiometer, or not potentiometer, but capacitor in there, and you flatten it out. It is I guess I should have said that first.
Cool.
Everyone over in the chat room.
Yeah, I hadn't had to do that on my other scope too much, but on that little DSO, I think it's DSO 138 when I built one time on AmateurLogic, I did have to tweak around with those when I put it together to get that right.
Yep. Yeah, I've had to do it on most scopes that I fool with, but you generally only got to do it once, and it's there. So this one actually comes with a little adjusting tool there. It's basically an alignment tool. It's got a metal tip, so it fits in there better, but you wouldn't want to do this with, say, a really, a regular metal screwdriver because, well, it's just not good. So we've got it on times 10. There's a little hole. I'm going to throw it off. Okay. Now you see that rise there at the very front, or that little spike. No, not the spike in the chat room. If you go the other way too far, it goes opposite. What you want to do is just square it up there. See, I can change the time base a little more. And then we can see the shoulder there is kind of
Slumping.
kind of slumping. There we go. That might still be a little bit off.
It's a little off.
Get it down to that line there. Oh yeah, you can tell easier then. It's also a lot easier to do if you are looking at the scope instead of at a computer monitor. What is the purpose of the prescaler function on a frequency counter? Is it A, it amplifies low-level signals for more accurate counting?
B, it multiplies a higher frequency signal so a low frequency counter can display the operating frequency?
C, it prevents oscillations in a lower frequency counter circuit.
It divides a higher frequency signal so a low frequency counter can display the input frequency. A prescaler. I don't think it's C.
I'll agree. It's not C.
I want to say it amplifies low level signals, or it multiplies a higher frequency signal. Multiplies a higher frequency, so a low frequency counter? No, it's not going to be B either.
Yep,
it's going to be A or D. Amplifies a low signal. Divides a higher frequency signal. I don't think it's like a preamp. It's a prescaler. I think it's going to be D. Divides a higher frequency signal so a low frequency counter can display the input frequency. Kind of like the voltage divider I did on my little Arduino project, because my Arduino could only measure up to 5 volts, but I needed to measure up to 16 volts from my power supply. So I built that. I'm thinking it's something along the same lines of that.
Okay.
I don't think it's an amplifier, but I don't know for sure. But I think it's either A or D, and I'm thinking it's D.
I'm going to agree with you, just like everyone over in the chat room. There you go. It divides a higher frequency signal so a low frequency counter can display the input frequency. And I've seen this on frequency counters.
What a coincidence.
Yep. What a coincidence. But I haven't seen it on any recently, although I'm sure they still do some of them that way. But there'll be a prescaler that you can turn on, and it's sort of like a times 10 or times 2 or whatever the multiplier is, and it does exactly that. It's actually dividing the frequency of the signal going in to read a lower number. B almost could trip you up, but if you think about that for a minute, that doesn't make any sense at all.
No, it doesn't. That's what I had to take. I did a double take on that one, and it doesn't really make sense.
Yeah.
You're going to multiply the higher frequency so the low frequency counter. That doesn't even add up.
No.
What is the effect of aliasing on a digital oscilloscope caused by setting the time base too slow? A false, jittery, low-frequency version of the signal is displayed.
B, all signals will have a DC offset.
C, calibration of the vertical scale is no longer valid.
Or D, excessive blanking occurs, which prevents display of the signal. What is the effect of aliasing on a digital oscilloscope caused by setting the time base too slow? It's not B. It doesn't have anything to do with a DC offset. C, calibration of the vertical axis is no longer valid. No?
Actually, I think I know the answer to this one. At least what I think I know.
Excessive blanking occurs, which prevents display of the signal. No. Well, it only leaves one. I said no on all the others. A false, jittery, low-frequency version of the signal is displayed. What do you think, Dean?
That's what I think it is.
Okay.
Aliasing, that's kind of what aliasing is on graphics as well.
Chat room, 100% A's.
Hey.
And it is.
Cool.
All A's. You know?
We didn't even need to put the batteries in the buzzer tonight. At least not for the first half.
Not for the first half. I hope you didn't just jinx us.
Could have happened.
Yeah.
You never know.
Well, what do you say we take a quick break, sniff around the room for the source of the electrical fire that's still, I don't know, I don't think it's gotten any stronger since
No,
we started.
actually, it doesn't seem quite as smoky in here.
Yeah, I'm thinking it may be that air conditioner, although I don't smell it if I smell right at it. Anyway, don't go away. We'll be right back, barring any electrical emergencies. It's that time of year again. Field Day is June 26th to June 27th. Icom has the base station of your dreams with the IC7300 and 9700 SDR transceivers and the portable SDR transceiver, the IC705. Be a Field Day leader with Icom. Icom's IC7300 is a high-performance, innovative HF transceiver with a compact design that will far exceed your expectations. This innovative HF transceiver digitizes RF before various stages to reduce the generated inherent noise in different IF stages. The IC7300 is the radio that changed the way entry-level HF is designed. RF direct sampling, 15 discrete bandpass filters, large 4.3-inch color touchscreen, real-time spectrum scope, and SD memory card slot. Create your own band opening with the IC9700. Bring direct sampling to the UHF-VHF weak signal world. This all-mode transceiver is loaded with innovative features that are sure to keep you busy. 4.3-inch color touchscreen, real-time, high-speed spectrum scope, and waterfall display. Smooth satellite operation with 99 satellite channels. Dual watch operation and full duplex operation in satellite mode. Expect top performance on Field Day with Icom's IC9700. IC705 is the perfect transceiver for hams who enjoy what both the great indoors and outdoors offer. Features and functionality at the tips of your fingers in a portable package, covering HF, 6 meters, 2 meters, and 70 centimeters, and weight is just under 2 pounds. See the IC705 webpage to view accessories and free software available for download. For more information on all these great Field Day choices, visit icomamerica.com/amateur.
So courtesy of Icom America, every month we have a drawing for an Icom cap and an Icom Ham Crew t-shirt. If you want to be entered into next month's drawing, send an email to hamcollege@AmateurLogic.TV. You don't really have to have a call sign or anything. All you need is a name and an email address. And we will do a drawing for it. And hopefully you'll be the lucky winner of Icom Ham Crew shirt and a cap. And then usually Jesse puts some extra goodies in the bag as well when he ships it out.
And we've just drawn a lucky winner here. It is, well, let's see. He actually included text on his email.
He did.
He
Went
said,
all out.
"Hello, Prof and crew. KC9TPR Bill." It's Bill Dabbs.
Oh, cool. Yeah, he's
I'm not sure if he's in the chat room tonight or not. I don't think so. Okay.
No, I don't see him in there.
Okay, well,
cool. Congrats, Bill.
Yeah, congrats. Which of the following is an advantage of using an antenna analyzer compared to an SWR bridge to measure antenna SWR? A. Antenna analyzers automatically tune your antenna for resonance.
B. Antenna analyzers do not need an external RF source.
C. Antenna analyzers display a time-varying representation of the modulation envelope.
Or D. All these choices are correct. Well, these are not all correct, so I know it's not D. Antenna analyzers automatically tune your antenna. They do not tune your antenna. They'll tell you if it's out of tune. C. Antenna analyzers display time-varying representation of the modulation envelope. Nope. Antenna analyzers do not need an external RF source. That's your answer right there. B. Bravo. And they actually have their own RF source in there.
This is
similar to that. exactly like that.
And MFJ, this is a 259C. I think they're making the 269s now.
Okay.
And this one, there's actually an oscillator in it. When you turn this thing on, it's generating a little RF signal, and it comes out right here where it's hooked to the antenna and shoots a signal down there and does your measuring with it. So
Should we see if I'm right?
it's a good point. I've already looked at the chat room, and everybody says you were right in there.
Well, it must be right then.
And I was going to agree with you.
Okay. Yeah.
These are really handy.
I know, yeah, it is handy.
This is a classic right here. There's a lot of different antenna analyzers out there now. This is probably one of the most popular ones ever sold, though.
Oh, yeah. Yeah, it is. It's classic design, and it's kind of a staple. Every ham should have one, I think.
Yeah.
I've got one like this. I think it's the model maybe prior to this, and I've also got the little UR kit I got from MFJ as well. They sell those, and it's really nice, little compact SWR. Antenna analyzer about that big. Runs off a couple of batteries. It's really nice for taking out in the field.
Oh, yeah. There's a lot of different models. Well, MFJ has a number of them, and there's other manufacturers as well. You know, I never really considered one much until I got one and started playing with it, and then said, yeah, that's the only way to go. Why would you ever go back to an SWR meter? After you've used one, it'd be difficult. You can. Yeah. I mean, if that's all you got, that's all you got. But
yeah, but it sure does make life a lot easier.
And faster, too.
Which of the following measures SWR? A spectrum analyzer.
B, a Q meter.
C, an ohm meter.
Or D, an antenna analyzer. Okay, well, I know a spectrum analyzer doesn't do that. It analyzes spectrum. B, a Q meter. Well, we know that measures Q, or the quality of a circuit, or how sharp it is, or the bandwidth, or any number of things you want to say about it, but not the SWR. An ohm meter. An ohm meter is, that's a DC voltage is sent out to measure the resistance of a circuit. It doesn't really tell you anything about impedance, just the pure resistance. And an antenna analyzer, well, you know, that's the best looking answer there, you know. You're talking about antennas, and we're measuring SWR. I'm going with D, just like everyone in the chat room.
And we've got one sitting right here.
Yep.
Could be a clue.
And it says SWR on one of those meters, doesn't it?
Does, right here.
Yep. It's good enough for me.
I'm going with that.
Okay. That was a good answer.
Clearly.
I don't think anybody's missed one tonight in the chat room.
Now, they actually been pretty easy so far, I will say.
Yeah. Well, I kind of knew they were in test equipment. Yeah, it's something that a lot of us have been using.
Yeah, this is the extra exam, so if you've made it up through general, there's a good chance you've used a lot of this stuff.
Yeah, maybe. Which of the following is good practice when using an oscilloscope probe? A, keep the signal ground connection of the probe as short as possible.
B, never use a high impedance probe to measure a low impedance circuit.
C, never use a DC couple probe to measure an AC circuit.
Or D, all these choices are correct. I don't think it's going to be D. It's a good practice. Actually, the way it's worded, it sounds like they could all be good practices, doesn't it?
Yep.
Use a high impedance probe to measure a low impedance circuit. Use DC coupled probe to measure an AC circuit. Nah. I don't think you use a different probe. I think it's going to be. I know it's important to keep those ground probes short. The little ground clip.
You talking about like this?
Yeah, that's exactly what I'm talking
can't really
about.
see that, can you?
Yeah, you can see it.
That's pretty short.
I think that's going to be the answer A.
Hey.
I'm not 100% sure, but I think it's going to be A.
Yeah.
Keep the signal ground connection of the probe as short as possible. This is very short, tiny little wire right there, too.
Yeah. We had a couple of different answers on that one. I'm going to agree with you, though. I think it's A as well.
D. It's worded pretty tricky, so you'd think D could possibly be it. Never use a high impedance probe to measure a low impedance circuit.
Yeah, well, B, if you're measuring a low impedance circuit and you use a high impedance probe, all you're essentially doing there is you're not loading the circuit down by using that high impedance probe, so that doesn't hurt a thing. Never use a DC coupled probe to measure an AC signal. No, I mean, you do that just about any time you turn your scope on, it's going to come on set for DC, and you have to switch it to AC if you want to. Doesn't hurt a thing if there's DC on there, as long as you adjust your voltage to where it's.
But it's the same probe, right?
Same probe.
So that's why I didn't think that's.
Yep. As a matter of fact, all probes, scope probes that I know of, are DC coupled, because you can measure DC with them as well if you've got DC on your scope. And so, yeah, it can't be all of these choices either.
Which of the following displays multiple digital signal states simultaneously? A network analyzer.
B, a bit error rate tester.
C, modulation monitor.
Or D, a logic analyzer. Which of the following displays multiple digital states simultaneously? Multiple digital signal states simultaneously. A network analyzer, that's not necessarily really used for digital signals. A bit error rate tester, no. That would tell you if there was errors in the signal, maybe. A modulation monitor, of course not, because that measures modulation. I would say, I'm going to say a logic analyzer, because typically those things can look at multiple signals at the same time. Now, if a logic probe, which is what we used to use, was just a little probe you could measure a high or a low at one point at a time. Logic analyzer is, I believe they have multiple inputs on them, so you could look at multiple digital signal states at the same time. Well, let's see. Everybody in the chat room is saying D, I think.
Yeah, looks like it. Mostly.
Let's see.
Oh, there's one that wasn't D, but now it is. So it must be D.
Must be D. Okay. And it is. How should an antenna analyzer be connected when measuring antenna resonance and feed point impedance? A, loosely couple the analyzer near the antenna base.
B, connect the analyzer via a high impedance transformer to the antenna.
B, loosely couple the antenna and a dummy load to the analyzer.
Or D, connect the antenna feed line directly to the antenna or to the analyzer's connector. Okay. Loosely. I'm just going to go ahead straight for the kill on this one. That's got to be D. Connect the antenna feed line directly to the analyzer's connector.
So
antenna resonance and feed line. So yeah, so hook your coax straight up to the PL259 or the SO239, whatever connector right here, and let her go.
So you're saying if I handed that to you and said, here, go stand out at the base of my antenna, I wouldn't get a measurement. If I wanted you to loosely couple it.
Oh, no, you're not going to know.
Okay.
No. It's got to be directly coupled to here, to the connector on the antenna analyzer.
I'll agree. Yep. How'd they do in the chat room? They all agreed on that one. Now, that's pretty good. I mean, it does say antenna right there.
Yeah. It'd be pretty hard to mess that up.
Yep. Loosely.
I imagine somebody could mess it up, but it's not likely.
Yeah. What loosely coupled would mean is you just kind of like hold it next to whatever you're trying to measure, and that's not going to do anything. And if you connected using a high impedance transformer, you're not measuring the antenna anymore. I mean, you're measuring the impedance, sort of the transformer there. And I don't know about loosely coupling an antenna and a dummy load. How would you loosely couple a dummy load?
I mean, I don't know.
You don't connect it if it's loose, you know. Yeah, I don't know. Fortunately, it is D, though. You just went for the kill on that
Straight
one.
for the throat.
Yep. Oh.
Speaking of that.
You know, say, just out of the blue here, I don't have an AmateurLogic shirt on tonight.
I noticed that.
I do have this Last Man Standing shirt
from
the Amateur Radio Club, and it is a nice shirt, but that's not the show I'm watching right now. Neither is AmateurLogic.
Yeah, it's not, but I'm representing.
So if I needed, say, a Ham College shirt, where could I find one?
Well, you can actually get it at the same place I got this shirt. It's an AmateurLogic shirt, but you can get a Ham College one in the same place. Shop.spreadshirt.com/AmateurLogic. We've got Ham College swag there and AmateurLogic swag. Cups, caps, shirts, jackets, backpacks, travel mugs, all kind of stuff in there. So check it out. There's got to be something that you really need in there.
There is a chance, there could be something you really need in there.
They changed the URL on it. It used to be AmateurLogic.spreadshirt.com, but now it's shop.spreadshirt.com/AmateurLogic.
I don't have a Ham College shirt other than the sweatshirt, and it's just a little hot for that tonight.
Yeah.
Maybe I ought to get a Ham College t-shirt.
Yeah, I was thinking the same thing. When I was looking for in there for what I was going to put on, I decided to wear this just for representing, but I need to get one too.
Around the 15th of each month, it's Amateur Radio's original and longest-running video podcast, AmateurLogic.TV, with hosts George Thomas, Tommy Martin, Emil Diodene, and Mike Morneau. Roughly, here's what I have. The bottom trace here is ground.
While the elements will jiggle some, they're actually not too bad. It's light.
After putting it together, I decided to test everything, so I ran in 12 volts, and I'm measuring the output here.
No, it's not too windy right now, Jim. It was yesterday.
We're in the antenna switching matrix. Any one of our 6 broadcast transmitters could be connected to any of the 22 antennas.
I personally am so thrilled that George got the special award. Well deserved, my friend. That's really cool.
What about the Super Bowl, Emil? Did you go to the Super Bowl, or were you at home operating that night?
Tuning my amplifier, and I lost power in the shack and went outside. The house lost power. And the whole neighborhood went out for about 30 minutes. I don't know what happened.
Wow. That explains a lot. Now we can take this and put it over inside our box. It's flush to the bottom. If we were to rotate, we can see that thing goes all the way through. So we'll have a hole in the bottom.
What ammunition do you use in there?
Actually, you can use black powder. You can use WD-40. You can use, anything combustible. You just have to use the right quantity, and we assume no responsibility for mishaps.
Here's what it looks like after I've got them all soldered together and heat shrinked up. Okay, let's give it a try and see how it worked out. So there you have it. The hula loop. No, you can't null out the dogs barking.
I have 2 thin film solar cells to run this. Looks like a little mini weather satellite, actually. And I'm using guitar string for the antennas.
I particularly like that last one there. $29.99. You can get a 50-foot garden hose extension cord combo.
Do not get cord wet. Now, most of these J-poles are built with metal elements or tubing. The reason I chose wire for this one is the length of this particular one. So I wanted to hang it from the tree so I can hoist it up there.
Yeah.
Go fishing.
We couldn't find the reel.
Yeah.
Is that what that is?
All right, Tommy, sing the theme song here.
What you doing?
Feeding the chickens.
Well, are you going to take the challenge?
Yep, I plan to. You?
I'm thinking about it. What about the big guns? Think they'll win?
They didn't last year, but then they didn't show up either.
Is that why you're feeding the chickens now?
Yep. Champions are never afraid of competition. Will you take the challenge? See foxmikehotel.com/challenge.
I recognize that voice.
I recognize the chickens, too. Yeah.
Do you?
Yeah.
They yours?
No, those are Frank's.
Oh.
Yeah. I think he's got them upstairs in the ham shack. I'm not sure. I'm not sure where he has those chickens. That's our friend Frank Howell is sponsoring that event.
Cool. Yeah, I'll have to check that out.
Yeah, because most of the contests are, I say most, majority of the contests, the really big stations with the, big antennas, big amplifiers, big signals win most of the contests, and this is one just for low power, so.
Yeah, that's cool. It's a good idea.
Yeah. I mean, the big gun stations can participate in it as well, but if you're using low power, you're racking up the points quicker. So, yeah.
That sounds like fun.
Sounds like a fun contest coming up soon. No, it wasn't ducks, Baldrick.
No, those were chickens. When you first hit that by mistake, I heard the chickens. I'm like, what in the world is he about to play?
Ham chickens. You know what I thought of when I first heard that? Ham seating chicken.
Oh.
You know what I'm talking about?
Arnie?
Yep.
Yeah. I forgot about that. Yeah.
Yeah. HAMSEATING. Chicken.
Mm-hmm.
Is it .org or .com?
.com.
It's like May the 19th was their last event there.
That's only 9 days ago.
Yeah. Well, I didn't know how active.
That's their club, right? Arnie's club.
I think it's a club or it's a group of them that eat chicken. It's a bunch of chicken eaters. I know that. You told us about it, but you ran it all together as one word. So we were trying to figure out why hams were seating chicken.
Yeah, I know. Didn't make much sense.
Yep. Email has the answer. Every Thursday, some hams would meet and eat lunch at Ryan's, and we called it Hams Eating Chicken. Ryan has since closed, and now the location for Hams Eating Chicken every Thursday is announced during the Tuesday net. And that's in Columbus, Mississippi. That's
I think that's the Lowndes County Amateur Radio Club or something. Lowndes County something club. I don't know exactly what they call themselves, but it's Lowndes County Am Club. Cool. Yeah,
So
I kind of forgot about that. I'm going to go back when I get home. I'm going to look at that site and look over and see what they've been up to. I haven't really heard too much out of those guys lately.
So Kevin's saying, so now it's hams eating burgers. I've seen that.
That works too.
Yeah. That used to be what we did after the Jackson Ham Fest here.
Oh, yeah.
For a lot of years.
Whataburger.
Mm-hmm.
Yeah, I guess we ditched Whataburger and moved to Five Guys.
We did, and I can't say that I'm disappointed with that choice. It's
a good choice.
It's been good. Well, what's going on Tuesday nights? You know, we've mentioned this before, but there's a special thing that happens every Tuesday night.
Oh, it's extra special. The Amateur Logic Soundcheck Net. It's at 8 p.m. Central Time or 0100 UTC, and it's a multi-mode net. We stream it live on the YouTube stream. If you're watching this stream live, then you can find the net right there as well. If you want to participate, we've got connections for just about any mode you can think about except HF single sideband. So we've got Echolink, All-Star. I'm not going to read the list, but you can see them right there. You can get in on the easiest one, I guess, is Echolink if you're not into the other digital modes. Almost everybody's got an Echolink account. But anyway, check in and join us. It's a lot of fun. It starts right at 8 p.m. We have pairs of operators, or 4 pairs of operators that rotate who's going to call the net. And it's a lot of fun. So you're encouraged to check in with multiple modes. If you check in with D-Star, wait till the next one and check in with Echolink and test out all the modes that you've got. It's kind of encouraged. We usually have a question every week of some ham variety, and it's a lot of fun. It sparks some interesting conversation there. And if you got some free time on Tuesday, come check it out. I think you'll like it.
Mm-hmm. And if, we don't really have any fraternities here at the college.
No.
But we do have a lot of social stuff going on, and you can find us throughout the month at facebook.com/groups/hamcollege or /AmateurLogic.
Yeah, you can follow us on Twitter at Ham College. We're also at Ham College at Amateur Logic as well. But anyway,
and you can. Well, I can't see what it says there. Let me see if I can.
MeWe.
Yeah.
MeWe.com/join/Ham College.
Or groups.io/G/AmateurLogic. So any of those places, catch up with our high society.
Yeah, we've also got, it's not on the list, but we've also got an Amateur Logic Instagram account. You can follow us there. We usually don't post much to it unless we're doing some type of an event. And with all the stuff that's gone on the last year and a half, hasn't been much of that going on, but that should be picking up here shortly. So you may want to join that group as well.
Yep.
Or follow that account, rather.
And if you'd like show notes of what was in each episode, you can do that at the AmateurLogic.TV wiki. AmateurLogic.TV/wiki.
What a convenient name.
Did kind of work out.
URL.
Yeah.
It did.
Well, with that, I think that's all we've got for tonight's show. 100% score. Everyone, well, yeah.
May not be so lucky next week.
No.
This extra stuff, this might be the easiest group of questions that we've had since we started the extra exam.
Yep. And we want to give a shout out to a recent graduate here who just finished her studies and passed her exam with flying colors on the general exam. Kelly, and I don't remember Kelly's call sign right off, but of Marty and Kelly.
Awesome. Yep. Congratulations, Kelly.
Yep. And I can't remember the score now. Was it 100%?
I'm pretty sure he said she didn't miss any of them.
Yep. KE0EWK. All I can say is I think she probably did better on the exam than the faculty did.
Yeah. I think she did.
She nailed it. Didn't miss a question. Finished in 9 minutes.
Wow.
Yeah, I know she did better than the professor did.
That's impressive.
Yeah,
You know, she's actually corrected us a couple times on a few things as we've gone along through here as well.
and we all came out better because of it.
Yeah, absolutely. So it doesn't surprise me that she did so well.
Yep. Wow. Congratulations, Kelly. Well, any final thoughts before we put the ribbons on this one tonight?
No, it was a fun one. Like I said, it was kind of easy. So those of you that came here looking for some buzzer action, you'll have to come back next month, and there's a good chance you could hear some then.
Yeah, I don't think the questions will be quite as easy as they were this month.
I doubt it.
Yeah. All right.
And hopefully the building will still be here. Or that you'll know if we're in an alternate location.
Yeah, true.
It's really not funny.
No. And I'll just say the next Amateur Logic is going to be on the 15th of the month, around about there. So join us then live when we'll have the cheapo man himself, KE5QKR, and Magic Mike, VE3MIC, and the whole crew, the Dean and myself here. We don't know what we're going to be talking about yet, but it's generally something.
Generally cheap.
Generally cheap. Yep. That is
at least
correct.
part of it.
Yeah. And don't forget about Amateur Logic shorts. On the weeks that we do not have a ham college on Amateur Logic, we've been posting little short videos to the Amateur Logic YouTube channel. Go there and check those out as well. It's just little brief segments like you would see on Amateur Logic, although they're not the same ones. And you can check those out during the off weeks. And
yeah, if you watch on the Roku or Amazon Fire Stick or one of those other things using our app, go join the YouTube channel. Subscribe to the YouTube channel, because those shorts are only there. If you don't do the YouTube channel, then you're going to miss them. We don't publish those to Roku and the others. So anyway, be sure and go do that so you won't miss out.
Okay. Well, 7-3 everyone. Thanks for joining us, and good luck on your test.
Yep, 73 everybody.
Propagation protection. I wonder if I've got it on manual focus.
Probably.
What?
Probably a horrible picture.
That's scary. That's all we can see. You know, I was just thinking, I think just before the show, a little earlier this afternoon, I was thinking, you know, the only... That's not what
I wonder if they heard that.
Yeah, they did.